G'day viewers. In this segment I'll provide an introduction to HTTP, the Hypertext Transport Protocol. So HTTP is the basis for the modern web because it's the network protocol which is used to move web resources that make up web pages between all of the clients and servers, or servers to clients maybe I should say. In this segment I'll give you an introduction to HTTP and talk about where it fits in the context of the web. And then later on we'll talk about the performance of HTTP in more detail. Okay, so beginning with the web, I guess. The web, this man is credited with the invention of the web. It's Tim Berners-Lee. He developed the web when he was working at CERN in Geneva, starting in about '89. From that time onwards, he and his collaborators came up with the first browser, server, and the first implementation of the HTTP protocol, which holds all of these pieces together. Within just a few short years, the web was popularized by the browser Mosaic, was a different implementation of the system, which had in some ways a more graphic user interface, and it really took off as it captured people's imagination. And very soon after that, Netscape was founded. The first World Wide Web conference, the first International World Wide Web conference happened in '94, and we were away. Very soon, the web became the dominant internet application, and it has been since about the mid-1990s. Tim Berners-Lee now directs the W3 consortium, so that's the World Wide Web consortium that standardizes the behavior of the web. Okay, so now we know a little bit about where the web came from, or we've refreshed our memories. Here's the overall context for the web and how HTTP fits, because it's really HTTP that we're going to look at. You can see here, there's the web browser in the middle, and the web browser is using the HTTP protocol, sending requests and getting responses to talk to web servers and to fetch web resources. Now, we're used to looking at web pages. Here's the page over here in the left. But I assume you know that a web page is really a set of related web resources. There might be the HTML text, the images, CSS style sheets, JavaScript that holds it all together, and so forth. So while we're used to looking at entire web pages, the HTTP protocol is really designed to deal with individual web resources, and it's the browser's job to knit them all together into the web pages and provide us the experiences that we're after. Just drilling down a little bit, we talk about the context for HTTP more. I've drawn one of our familiar protocol stacks here so you can see where it fits in. So we can see here HTTP. It's this request response protocol. So you can see it, browser sends a request to the server replies with a response. HTTP is implemented on top of TCP, typically running on port 80 is the well-known port that most web servers sit on. Now, because it runs on top of TCP, TCP is providing a byte stream for long messages and reliability. So great, HTTP gets those features. What it really needs to implement now is the request response series of interactions to build a web page. And I'll just note that, as usual, I've shown the browser here as an application on top, but really HTTP is typically implemented in a user level program. So the app, if you like, probably has an implementation of HTTP somehow folded in, maybe via a library, and the browser code itself. Okay, so this is the operating context for HTTP. Let's just look at how a web page is fetched to, again, just learn a little more about the relationship between HTTP and web pages. So I picked an example URL for a page to start with. Here it is. It's a page on Wikipedia for Vegemite. So if I write out the URL, you can see that it has several parts. The first part is the protocol part. That's HTTP. We're only interested here in HTTP URLs because they're the ones which are fetched with the HTTP protocol. If this was something different, a different protocol would be used to fetch it. And then the remainder of the URL has two components. One is the server component. That's really telling us which host. So you can see this is a DNS domain name. It's the name of our host, the server. And the part after this, well, that's the identification, the name of the page that resides on that server. So we go through several steps for a browser to be able to retrieve and display this page. And I'm listing them all here just so we can go through them and get a sense of where HTTP fits in. This is more than HTTP. In fact, the first step is often to resolve the server hostname to its IP address using the DNS. We've seen how this is done with the DNS. We need this to be able to contact the server. Once we have the IP address for the server, we've got to set up a TCP connection. HTTP runs on top of TCP, so we can't do much till we open the TCP connection. After we do that, we can send our HTTP request. Now we're getting to HTTP proper. And then, once having sent the request, the browser will wait to receive the response from the other side, from the server. It will simply be sent on through. And then there is a large step here. I've started just because to indicate that there's a lot of complexity that goes in here. This step is really the fetching of embedded web resources. If you have a page which has 3 images in, well, you would have to go and fetch those pictures to be able to display the page. And you need to fetch them before you can render or display the page. The reason I've started is that this step is very complicated today in modern browsers because some of the resources that we can fetch are not simply static content to display, but they're programs such as JavaScript. Browsers need to execute those programs. In the course of executing those programs, they may discover that they need to use HTTP to obtain further resources for display. So pages have really become not simply a static picture that we're moving around, but real running application code, as it were, a real dynamic system. And finally, after this process is finished and a page is displayed, if it ever finishes, that is, because you can continue to interact with the page, at some stage there'll be a cleanup step, and we'll tear down maybe any TCP connections which are no longer being used. Okay, so this is the overall web page fetch, and HTTP is used as part of it to get every web resource. How that happens is going to depend on the execution of the content. And just for the sake of completeness, since I've started talking about programs and web pages, let me briefly go over static and dynamic web pages. This is actually not terribly relevant to HTTP, the protocol, which is what we're focused on in a networking course, but it is of course very relevant just to how well the web works. So you will surely have heard of static and dynamic web pages and understand somewhat about the differences. I'll go over that. In a static web page, the file contents are unchanging. They're whatever the contents of the file were. An image would be a good example. Maybe you get that from a URL and that's just what it is, the contents of that image. The contents of a file, which is the image. Dynamic web pages, on the other hand, are the result of program executions. So, and this program could be executed on either the server, the client, or both. The common languages that we see today are, and there are actually many that can be used, so these are just examples of very popular languages today. JavaScript, running on clients, and systems like PHP running as part of the server. So here, this figure just illustrates how dynamic web pages can fit in. To fetch a dynamic web page, you might just make an HTTP request as usual. The request doesn't care if it's static or dynamic. Now, when this request gets to the server, a program here would be run that would often consult a database and the input parameters you provide as part of the HTTP request to construct the output page. That's the output of the program. It would then go back to be displayed on your browser. However, the contents that comes back may include a program. This program would be run on the web page. Even if it doesn't cause any other content to be fetched right away, as the user interacts with the web page, you may trigger the execution of further parts of this program. And this program could then go off and request yet more content from the same server or a different server. Again, that content could be produced by a program, by consulting a database, and it could then be sent back to the program, and it could then affect the user interface. So you can see in this way, we've turned the what used to be simply a static page, like a newspaper or something, into an interface that evolves as the user interacts with it. It's really a running application. HTTP is just the part that's used over here, so it's not terribly concerned with how these programs are run. Now, the HTTP protocol itself, since I'm going to tell you a bit about it, I'm going to start just by giving you this timeline to show its evolution. HTTP has been around since the very beginning of the web. You can see here the first versions were used around 91 maybe, something like that, was when a version called 0.9 was popularly used in browsers. So this was pre 1.0 HTTP. And that version very quickly gave way to version 1.0, which came under development. Actually, it wasn't until like 96 over here that HTTP 1.0 was standardized. So before that time, different browsers all had pre-standard implementations. Really, a de facto HTTP 1.0 was evolving based on common usage and what was important, and it was standardized after the fact. You can see in the middle here, well before it's standardized, Netscape added cookies as a feature to the way the protocol worked by adding new headers. This allowed stateful behavior on some clients and servers. It's very useful for many things in the way the pages work today. Also around this time in 94, some of the first versions of SSL were developed. SSL and also TLS as it's known today are part of what makes up HTTPS, the Secure Web Protocol. This is a very interesting subject, but again, as with some of the other security subjects, it's something that we're going to defer until later. So I'm not going to talk about HTTPS now, just HTTP. So version 1.0 was developed over a period of a few years and standardized, eventually around 96. By the time it was standardized, work had already begun on, right about then, people began to move ahead to HTTP 1.1 with other new features that we'll look at, including what's called persistent connections. And HTTP 1.1 was then standardized, I think it's probably this arrow here, with RFC 206A, and then later revised a bit. So you can see that along this path, HTTP 1.1 has been developed, and that much of this activity here has happened over a relatively short period of time. This has been the flurry of activity that developed some of the initial versions of HTTP. And after that time, we've had about something like a decade of relatively stable usage of HTTP. Now, the web certainly hasn't stood still in that time. Actually, this other bubble in here says that there has been a huge proliferation of many different types of content, different media types, different browser and server scripting technologies. But these technologies have had only a minimal impact on HTTP. So it's stayed fairly stable for quite a while. The implementations in browsers, really, it's the deployment of the HTTP 1.1 features, which have happened increasingly over this period. More recently, however, the clock has again begun to start ticking on HTTP, and I'll tell you about a new protocol called SPDY, S-P-D-Y, just briefly in the following segment. SPDY is a protocol that's now implemented in Chrome and Firefox by default. It's forming the basis of what's become called HTTP 2.0, which is an ongoing effort just to slightly improve the HTTP protocol to make the web faster. Okay, so I've given you an introduction to the context of the web and the HTTP protocol. To complete an introduction to HTTP, I want to tell you about some of the features of the protocol. And we're just going to talk about the messages. You know it's a request-response protocol, but nothing about what the request and the response looks like. So I'll talk about that a little bit, and in a subsequent lecture we'll talk about HTTP performance and see more about how and when the requests are sent and what that means for performance. Okay, so the HTTP protocol, well, originally actually it was a very simple protocol. It still is in some ways a request-response protocol. It's just had more and more options and features added over time. Many of typically the headers, originally the way they all started, is they're text-based commands and text-based headers. This is actually very convenient for debugging the protocol and observing what's going on. One fun thing that you can do, this makes an excellent lab, is to try it yourself. You can pretend that you're a browser and try and fetch a page and see what happens. You can do this just by running the telnet program on one of your clients, any system. It's not so easy maybe on Windows, but on most systems you can get a telnet program and run it. You can simply, to pretend to be a browser, connect to a host, such as nen.wikipedia.org on port 80, and then you can send an HTTP request. Here's an example of an HTTP request. Just get and give it the URL and the HTTP version to make it work. Actually, if you try this, it's important that it be followed by a blank line before the server will respond. Once you issue this request, the server should look it up and it will return an HTTP response, which will have headers, and it could be the content itself, hopefully, or it might be codes telling you where it's gone or something else like that. But this is a fun thing to do. Okay, so the HTTP protocol, it's request response. Let's look at the request first. The request is simply a command or a method, which is the name for a command. And there are, well, it looks like there are several different possible methods here. Two of them are really very popular and are the ones which make up the bulk of HTTP requests. And I've shaded them here. You can see there's a GET method. Well, that's the command you send if you want to get a web page. You just send a GET request. There's also a POST method. This is the command that's actually used if you want the client or the browser to be able to upload data to the server. When you're writing a mail message, for instance, on a web interface and you want to be able to send it, or some other kind of document and so forth. This you need POST as well as GET to be able to write, to be able to develop real applications that have a user interface and can do useful things. These are the two main methods. You can look up all of the other ones in the RFCs, but these are the two ones you really need. The response returns, along with the various content, which hopefully you're asking for, status codes, which tell you what's going on. The code you want to get is a 200 something. This is a success code. It says, yep, it worked, and here are all of the parameters for the content, and hopefully the content itself. Or maybe even code saying the content hasn't changed, so it's okay. You might get other kinds of codes, and you might have seen these in some places. 404 is a well-known error message, page not found. So you may well have seen web pages that say error code 404 when you're trying to access a URL that's not there. That 404 comes from the HTTP spec. It's one of the status codes. You might also have seen some of these other ones, internal server errors, forbidden. You typically won't see, although these are quite important, redirection codes like 301. Redirection would mean this page is moved from here to another URL. Maybe when you used a different server name than you're meant to use to access the content. If this code comes back, your browser will actually get it, realize it's a redirect, and try and retrieve the content from the new location on the web. That's why as a user you probably don't see this code much, but it's quite important in practice. And finally, both the request and the response can include, as well as the content itself on the response, they can include many headers, which just describe the context of what's going on and provide more detail to go with the request. Here are some examples of headers. Typically they're text fields with a fairly simple format. An example of one is content type : text/HTML. The content type header is telling you, surprise, the type of the content that's been returned in a response. Another header would be cookie : lect equals 84-HTTP. Now I just made that up, but that's an example of a cookie that might be sent from a client to a server to tell it some state it has, maybe about the lecture you're watching right now. There are dozens and dozens of different HTTP headers. You can look them up in the spec. I've just summarized some of the groups of them in this table. So many of the headers describe browser capabilities. So these are sent from the client to the server. They might describe, for instance, what language and kind of content encodings you will accept. The user agent is also a popular one. So the browser will tell the server what kind of browser it is. Just because for implementation reasons, the server may want to return different responses depending on the browser. Okay, so there are also many caching related directives which are sent in both directions, from the browser to the server to specify, well, some of the contents, its situation, what it already has, and from the server to the browser to specify how returned content should be treated for caching purposes. Examples of headers here, actually I'll get to some of these in the next lecture when we talk about caching, but they're things such as when the content expires, what date, or when it was last modified, a timestamp from the server for this version of the content was created. There are also context information which is sent from the client to the server. I mentioned cookie is a state that the client is holding, which the server wants to know about to implement stateful interactions. There are all sorts of other things. Referrer tells you the page that the browser was previously on when a link was clicked to visit this page, so it's providing context. Actually, it's misspelt there. It should be REFERRER, but this is a misspelling in the standard, so this is what's stuck. And finally, there are probably all of the headers that you were thinking about. The content delivery headers that are used from the server to the client to describe the content itself that comes back with the response. We talked about content type, maybe to say it's image/JPEG or something, but there is also the content length, the encoding, how it's being encoded for transfer, languages, cookies that the server is telling the browser to now maintain and set for the next time it wants to contact it, and so forth. So, in a nutshell, we've now looked at the basic operation of the HTTP protocol, requests and responses using all of these different formats. In the next section, I'll move on and talk about the performance of the protocol as we see how it's used in practice.